In this series of videos, I will perform activities meant to demonstrate some of the named thermodynamic processes. In this video, I will illustrate isochoric heating and isochoric cooling processes between different thermal reservoirs. I will try to limit commentaries. Please watch the video carefully and pause where needed. With some exception of freeze frames, the video is unedited. At the beginning of each video, I will go through an initialization step meant to set the n, that is, the number of molecules in the heat engine apparatus, at a consistent value. In this initialization, I am setting the gas temperature at about 40 degrees C, with no additional mass on the piston, at the largest volume position of the piston. This gives us the largest n that will ensure that the piston won't max out in the space of available volume for expansion in the course of measurement. We'll start the gas at room temperature. So this will be the volume that we keep constant as the gas undergoes isochoric processes. Now, as it undergoes isochoric heating to about 40 degrees C, we place additional masses on the piston to keep it at the same volume. I just place 200 grams. It looks like the additional 200 grams is too much, so I'll use 100 grams. So there's a total of 300 grams on the piston right now. Now, the gas will undergo isochoric cooling. And we remove the masses as the gas cools down to reduce the pressure so that as the temperature decreases, the volume remains the same. The piston doesn't quite return to the same position, and that's because it leaks a little bit. In a separate video, I characterized the leakage of the piston, and you can do more detailed analysis with that if needed. Now we'll do the isochoric processes between the room temperature and ice cold water at 0 degrees C. We will start from the ice water. So this smaller volume will be the volume that we keep constant about here. Now it'll undergo isochoric heating to room temperature, and we place additional masses, 200 grams. And 100 grams doesn't seem enough, so we'll go back to using 200 grams. Another 200 grams, so there's a total of 400 grams on the piston to try to keep the volume the same while the temperature increases by increasing the pressure. Now isochoric cooling back down to 0 degrees C, and we reduce the pressure to try to keep the volume the same. These are the 200 gram masses I used in this run of Isochoric heating and cooling for a total of 400 grams. So this is another run of isochoric processes between room temperature water and warm water, and also with ice water. We also have another trial of isochoric processes with a smaller value of n determined at the initialization step. Thank you.